Hello, today I'm going to solve number 68, text justification. Okay, let's read the problem. Given an array of words and with max width, format the text such that each line has exactly max width characters and is fully left and right justified. You should pack your words in a greedy approach, that is, pack as many words as you can in each line. Pad extra spaces when necessary so that each line has exactly max width characters. Extra spaces between words should be distributed as evenly as possible if the number of spaces in a line do not divide evenly between words. The empty slots on the left will be assigned more spaces than the slots on the right side. For the last line of the text, it should be left justified, and no extra space is inserted between words. A word is defined as a character sequence consisting of non-space characters only. Each word's length is guaranteed to be greater than 0 and not exceed max width. The input array of words contains at least one word. Okay, let's see the example. In the first example, the words list. This is an example of text justification, and the max width is 16. So let's see the output. Let's count the characters first. This character is 4, and the remaining 2 and 2. So we can calculate the total space as 8. So we can see that the two spaces are 4 respectively, because we can divide 8 into 4 and 4. Let's see the second line. Total space is 3, so we cannot divide evenly. So the first space has one more space, and the last line is not justified, which means that no extra space is inserted between words, as described in the problem. Okay, I believe you can understand the basic principle of text justification described in this problem. Okay, let's jump into the code. I implemented the full justify function, taking word list and the max width. This is the iteration using a word list. Through the iteration, I accumulate length of each word, and the count variable is increased. And if accumulated word size plus count minus 1 is bigger than max width, this condition is used to calculate each line. Count minus 1 represents the space between words in a line, and in that case, I is stored in last index, which is pointing the first word since the second line. So finally, the last index is pointing the justification, which is the first word in last line. We have to know the index of first word in last line, because we have to apply the different rule from other line. Actually, the last line is not justified. So this is the loop to get the last index. Okay, let's see the second iteration. Accumulate the word size and the line words count minus 1, representing space between words in the line, and plus the next word's length is smaller or equal to max width. We can add up the word in the same line, and we have to check if last line is started or not. That is stored in EOW, representing end of word. And we also have to check last word in the text. If the current word is the last word, or the accumulated word size plus the line words count, representing the space between words, plus the next word's size is bigger than max width, we have to calculate the total space. First, by subtracting word total size from max width, and we have to calculate the remaining space. If the current word is not last word and the line word size is bigger than 2, we calculate the remaining space by doing modular operation using the least space count, which is line words count minus 1. And this for loop is used to add a real string word to compose a string line. L words is actually storing the index of each word, composing one line. So this part is the option, storing each word into LW. which is representing a real string in a single line. If index j is the last word in the line, we just store the word without additional space because this is the last word. And the current word already surpassed the last index. We could see this line is last line. So we do not apply the justification algorithm. Instead, just add one space between each word. In else case, we should apply the justification algorithm. We can calculate the even space first and add the remaining space, decreasing it by 1. Sp is the function just generating the space as many as the size. If the current word is last word, or the line word size is 1, which means that a single word composes a line. In that case, we have to calculate the remaining space in its right side by subtracting line word size from max width, and we push back the line string into answer array. Through the iteration, we repeat this calculation line by line. Okay, this code performs 0 milliseconds. Thank you for watching. See you next time. Bye bye.